Hello everyone. So in this lesson, I want to look at sections 8.1 to 8.6. 8.4 is solving radical equations graphically and algebraically. Now, if you remember from what we've done in previous lessons, when we get to the equations part, like linear equations, quadratic equations, rational equations, we want to solve them graphically with a calculator and also algebraically. Now, if we look at these rules here, you would see that these rules look familiar. You have your y1 and then y2, and then you set your appropriate window, and then also you use the intersection method that is on the calculator, and then you may have one or more solutions, one or two solutions, and you find your x values. Now, problem 29 is a worked example, so I'm not going to be going over that. Problem 30 is a media example, but I want to go over that. Now, it says that we should solve this by graphing. So we have to go to the calculator and then use the calculator to solve this. Now, to solve this with a calculator, I'm going to do y1 for this and then y2 for that. So when I go to my calculator, I go to y equals, and then I'm going to erase everything. And then I'm going to put in my equation. So my y1 is 1 plus I'm going to put this in parentheses, 3x all divided by x minus 1. And then my y2 is going to be 3. I'm just going to use the standard window and see what I get. So this is what I have. Now you would see that there's going to be one solution for this. So I'm going to do second trace, and then I'm going to choose 5, and then I'm going to hit enter 3 times. Oh yeah, so my solution x is -2. Wow. And that's it. So my solution is -2. So that is how you solve these by graphing. Remember how I set it up? Because I think that this is the best way to set it up. Because remember, the calculator should understand that this is what you have. So you have x minus 1, everything under the division line. So you don't want the calculator to think that this is what you've done. You see that? And it's not going to be the same thing. So please remember that. So you just have to set it up in a way that it's not confusing. It's not confusing. So the calculator will understand what is going on. All right? Okay. I'm going to go back to the workbook. Where is it? Okay. So here we have x equals -2. And that is it. All right. Now, what about when you're solving this algebraically? This is the same problem. So here, how do I solve this algebraically? Now, I'm trying to solve for x, so I'm going to take the 1 away. I'm going to do a -1 here, and then I'm going to do a -1 here, 3x over x minus 1. Now, this goes to 0, so I have 2 equals 3x all over x minus 1. Now, I have two options. I could cross multiply, or I could multiply through by x minus 1, which is my LCD. So if I cross multiply, I have 2 times x minus 1, and then 1 times 3x, which is 3x. I have 2x minus 2 equals 3x. So 2x minus 2 equals 3x. Again, I'm trying to solve for x, so I do minus 2x here, minus 2x there. So I have -2 equals x. Wow, have the same thing. Now, you should always check your solution to see if you're right. So I'm going to do a quick check on this. Check. 3 equals 1 plus 3 times -2 all over -2 minus 1. So this would be 1 plus this -6 over -3. Equals 3. Now, negative will cancel negative. 3 will go into this 2 times. So you have 3 equals 1 plus 2, which is 3. So this is correct. So my solution is right. Sometimes when you check, you're going to see that you don't you don't have a solution because it's not going to work out. Now, what about this one, problem 33? In problem 33, you're supposed to solve this graphically, and it says sketch the graph from your calculator screen and indicate the viewing window you used. Now, if you want to, you could move this -3 to the left, and then it turns out to be positive. If you want to, you could do that. But if you want it to stay the same, then this is going to be your y1, and this is going to be your y2. So I'm going to go to the calculator and then set it up in that way. So my equation was going to erase everything here. So I had 5 divided by x, x minus 2, and I close this, and then I'm going to do -3, and then my y2 is going to be 1. I'm going to go to graph to check what I have, and then I do second trace. Remember, I have to draw the graph. Second trace. Now, because of the way it's set up here, I'm just going to move up and then get this closer to that, and then I'm going to hit enter, enter, enter. So what do I have? I have 3.25 for my solution. And because there's a graph, you know it is exact. So 3.25. Now you have to draw the graph. I use the standard window as well. So I draw this graph, and then my solution is x equals 3.25. Then you draw the graph. Now, what about solving this algebraically? Solving this algebraically. To solve this algebraically, what are we going to have? So, to solve this algebraically, I'm going to have I have to take off the -3, so I could do a +3 here and then a +3 here. So this is going to give me 4 equals 5 over x minus 2. Now I could cross multiply, so I have 4x or 4 times x minus 2 equals 5 times 1, which is 5. So I have 4x minus 8 equals 5. Now if I do a +8 on both sides, this is going to go to 0. So I have 4x equals 13. I divide by 4. I divide by 4. X equals 3.25. Okay? 3.25. Okay? And you want to check your answer. You know that, I mean, you got that from the calculator, so that is a check. But you can put it in. You could put it in and then check what you're going to get in the end. So if you have 1 equals 5 over 3.25 minus 2 minus 3. So 1 equals 5 over 1.25 minus 3. Now, what is 5 divided by 1.25? It's 4. Minus 3 equals 1. 1 equals 1. So this is right. So, yes, my solution is right. Okay. Now, what about problem 34? Now, for this one, I'm going to do it on a whiteboard. So, this is the equation that I have. 3 over x minus 4 over x minus 5 equals 2 over x squared minus 5x. Now, I'm going to have, first of all, I have to find the LCD. Now, with this one, now remember that with x squared minus 5x, if I want to factorize it, I have x out, x minus 5. So you would see that I have both of these guys in here. It's just like if I tell you to find the LCD of this. Now I know that 12 here, 12 is 3 times 4. So 3 is a factor of 12, 4 is a factor of 12. So the LCD is the biggest number, which is 12. That's this. So the same thing applies to this. Because I see x and then x minus 5 in this, that is going to be my LCD. So if that is my LCD, I could rewrite that as x minus 5 so that I can cancel out. So x times x minus 5. Now I multiply that on both sides. and then I do the same thing here. Again, even though I factorize it as the same thing, so for this part, this would cancel that. Now for this part, I'm going to do x minus 5 times 3 over x minus 4 over x minus 5 times x minus 5. Remember, I'm just doing this, okay? Distributing the LCD to those two terms. So this should be equal to 2. Now x would cancel x minus 5 will cancel x minus 5. So I have 3x minus 5 and then negative 4x equals 2. Okay? Now again, if I distribute the 3 to both terms, here I have 3x minus 15 minus 4x equals 2. Now if I do a plus 15 on both sides, this will go to 0. I have 3x minus 4x equals 17. So negative x equals 17. Now I'm trying to solve for x and not negative x. So I divide by negative or by negative 1. Then I have x over 1, which is x equals negative 17. And that's what I have. Okay. And then you want to check to make sure. You could put this in the graph to make sure if you're doing it right, or you could check algebraically to see if you're doing it right. Okay? All right. Now, what about problem 35? Problem 35, here we have x plus 1 over x equals 2. Now, the LCD is x, so I'll multiply through by x. Two times x. So x times x is x squared plus x times 1 over x is x over x, right? Equals 2x. Now, x over x is 1. We know that. So we are going to have x squared plus 1 equals 2x. Now, I'm going to move this across and then it changes to negative. Now, this is a quadratic. So I get a quadratic from here. Now, I have to try the AC method. If the AC method does not work, I'm going to use the quadratic formula. Now, my AC is 1. My B is negative 2. So I'm looking for two numbers that would multiply to give me 1 and would add to give me negative 2. So I have negative 1 and negative 1. So negative x and negative x plus 1 equals 0. So x minus 1 minus 1x minus 1 equals 0. So this and that are common, so they come out. X minus 1 equals 0. So you're going to have x minus 1 equals 0 or x minus 1 equals 0. So you're getting the same thing. X equals 1 or x equals 1. So our solution is x equals 1. And you want to check to make sure, right? You want to check to make sure. All right. You could go to your graph and then check the graph, your calculator, and then check. Okay. All right. Now with problem 36, I'm going to do that on the whiteboard, problem 36. So I have 3 over t plus 6 over t squared equals 2. Now I have, for the denominators, I have t and t squared. So my LCD is going to be t squared. So I'm going to multiply through everything by t squared. So t squared times everything on the left equals 2 times t squared. Now t squared times this, t squared times that. So you have t squared times 3 over t plus t squared times 6 over t squared equals 2t squared. Now, remember that t squared is t times t, right? T times t. So t times t over t, this will cancel that, so you have t left. So this will cancel this, and then you have t left. Now this would cancel that, and you have 1 and 1. So we have 3t plus 6 equals 2t squared. Now I'm kind of getting a quadratic. So I'm going to move this, and then it changes to negative. Move that, it changes to negative. So I'm going to have 2t squared minus 3t plus 6 equals 0. Now I'm going to try the AC method first. My AC is 12. My B is, my 6 goes there, and then it changes to negative as well. So that is going to be negative 6. Yeah. So this is negative 12 and then negative 3. Now I'm looking for two numbers, but I think it's impossible to get those two numbers. So I have to use the quadratic formula. Now to use the quadratic formula, I have to get my A, which is 2, B is negative 3, C is negative 6. My quadratic formula is x equals negative b. I might as well use a red for this. X equals, x equals negative b plus or minus b squared minus 4ac all over 2a. This would give me negative b, so negative 3 plus or minus square root of b squared is negative 3 squared, which is 9, minus 4a is 2, c is negative 6 all over 2 times 2. So I'm going to have this is equal to 3 plus or minus 9. Now negative 4 times 2 is negative 8. Negative 8 times negative 6 is positive 48 over 4. This gives me 3 plus or minus root of 57 all over 4. So sometimes you are forced to use the quadratic. You know that for the to use the quadratic formula. For the quadratic formula, you are always, no matter what quadratic equation it is, you always get, you can always use it to solve for your x. So here we are going to have x equals 3 plus square root of 57 divided by 4, or x equals 3 minus square root of 57 all over 4. And what is this going to give me? It's going to bring me to the first one, x equals 2.64. It's approximately 2.64, or x equals, or s is approximately equal to negative 1.14. And that is what I have. You could check with the calculator too. Okay, check with the calculator. All right. Now this brings me to problem 37, which is a media example. We are going back to what we started with in lesson 8.1, 8.2. Now, what is the domain here? Remember that we've studied that the domain really should be all real numbers except a number that is put in for x, or that replaces x, that makes the denominator 0. Because when the denominator is 0, the function is undefined. So x is going to be all real. The domain is going to be all real numbers except so you solve x plus 5, the denominator equals 0. So x equals negative 5, except x equals negative 5. Now, what is the equation of the vertical asymptote? Is going to be that x equals negative 5. What is the equation of the horizontal asymptote? Now, you find the highest degree term of the numerator is the highest degree x term of the numerator is x. The highest degree x term of the denominator is x. X divided by x is 1. So y equals 1. Y equals 1. Now, what about the vertical intercept? The vertical intercept. Now, for the vertical intercept, you have x equals 0, right? For vertical intercept, so f of 0. Now, you put that into the function, equals 0 minus 1 over 0 plus 5. So this is going to give us negative 1 over 5. So you have when x is 0, y is negative 1 over 5. Okay? Or negative 0.2. Now, what about the horizontal intercept? What about the horizontal intercept? For horizontal intercept, remember that for that, y is also 0. Y is also 0. So we are going to have 0 equals x minus 1, x plus 5. Right? So, what are we going to have in the end? If we decide to multiply through by x plus 5, we're going to have x plus 5 times 0, which is 0, x minus 1 over x plus 5 times x plus 5. So you have 0 equals x minus 1. So x equals what? 1. So when x is 1, y is 0. And that's it. Okay? Now, what about f? What about f? So this is kind of like going to less than 1. This equals, so x minus 1, so 12 minus 1 over 12 plus 5, which gives us 11 over 17. And that's it. Now, what about g? What about g? Now, for g, now we are giving output. We are finding the input. So x minus 1 over x plus 5 equals 3, or 3 over 1. So cross multiply. You have x minus 1 times 1, which is the same thing, and 3 times x plus 5. So you have to distribute the 3. So x minus 1 equals 3x plus 15. Now if I move this across, it changes to positive 1, so x equals 3x plus 15 plus 1. Then if I move this here, I have x minus 3x equals 16. Negative 2x equals 16. If you divide by negative 2, you divide by negative 2. So you have x equals negative 8. X equals negative 8 when y is 3. So that is it for this one, okay? All right. Now, this is a u-try problem. Again, you have the same idea. The domain, you have to solve for the denominator x. You have to solve for x in the denominator when you equate it to 0. So 3x equals negative 4. When I move the 4 across, I divide by 3. I divide by 3. So x equals negative 4 over 3. So all real numbers except x equals negative 4 over 3. So this becomes your domain. Now, what about the vertical asymptote? Is the same. So the exception becomes the vertical asymptote. Now, what about the horizontal asymptote? Now, when you look at the numerator, the highest degree x term is 15x. The denominator is 3x. So x will cancel x. 3 will cancel 15 5 times. So y equals 5. Okay. Now, what about the vertical intercept? Remember, for the vertical intercept, x is 0. X equals 0, so you put that in the function. So you have g of 0 equals, we have 15x, so 15 times 0 minus 12 over 3x, 3 times 0 plus 4. This goes to 0, that goes to 0. So you're going to have negative 12 over 4, which is negative 3. So when x is 0, y is negative 3. Now, what about the horizontal intercept? Well, the horizontal intercept, y is 0, so 0 equals 15 minus 15x minus 12 over 3x plus 4. Now, if you multiply through by that, this will cancel that. That will go to 0. So this goes to 0. You're going to have 15x minus 12 equals 0. Plus 12 plus 12. This goes to 0. So you have 15x equals 12. Divide by 15, divide by 15. So my x will give me 4 over 5. So when x is 4 over 5, y is 0. Okay. All right. Now I'm going to skip G of I'm going to skip F and G because I think you should be able to do that. But if you want the answers for G of 5, G of 5 should give you G of 5 should give you x equals -20 over 39. And then finding x when y is -8. Oh, this is x is -20 over 39. And then here we have G of 5, so y when x is 5 is 63 over 19. All right, so try that and see if you can get these values. Now, here we have an application problem. You and your family are heading out to San Diego on a road trip. From Phoenix, the trip is 354.5 miles according to Google. Answer the following questions based upon the situation. Now it says using the relationship distance equals rate times time. Now with your rational function, it wants you to write a rational functions of t, which is time, t of r. So r is your input, but r is your rate of travel. Then t is time. So time is the output. Now distance, of course, distance is constant, right? Because distance from San Diego to Phoenix is constant. So remember that D equals RT. Now we're trying to make T the output. So we divide by R, we divide both sides by R. So T equals D over R. Now we do know that to write a rational function, we need to put that in there. Now D is constant, so we have that 0.5 over R, like that. So this becomes my rational function. Now B says, provide a rough but accurate sketch of the graph. So I have to go to the calculator. And then I go to y equals. So I have 354.5 divided by x. And for this, I can just erase this. Now I'm going to go to my window because these are very big values. So, and this is a practical problem. So I'm going to do, remember this is my R. I mean, I could do to 120 or 140, right? Miles per hour. So 140. And then here, could do 0 to, I'm going to do maybe 150. I know that's time, but I'm going to do to 150. And then graph. Oh yeah, look at what I have. So you sketch this, okay? Remember your y is time, right? And then you have rate. Yeah. Okay. Provide a rough but accurate sketch. So we did that. It says you have to label. And remember, this is a media example, so you could watch the video. Now, and then put in your window. I did 0 to 140 and then 0 to 150. Now, if you average 60 mph, miles per hour, which is my R, how long will your trip take? So T of R is 60. So this gives you 354.5 divided by 60. Okay. And that I think should give you 5.9 hours. Now, D says if the trip took 10 hours, so time is 10, what is your average rate of travel? So 10 equals 354.5 hour. So you could cross multiply. When you cross multiply, you have 10R equals 354.5. Now you divide both sides by 10, and R becomes 35.45 mph. Okay? All right. Again, this is a media example, so you could always go back and then watch that. Now, E says, what does the graph indicate will happen when your rate increases? When your rate or your speed increases, what happens? Your time decreases. So as R increases, T decreases, okay? So as R increases, T decreases. Now, what about F? What does the graph indicate will happen as your rate gets close to zero? As R approaches zero, the time increases, okay? Because if your speed is going down, your time of travel is going to increase. Now, you do have a similar problem here. And this one, again, you and your friends are heading out to Las Vegas on a road trip. From Scottsdale, the trip is 308.6 miles, according to Google. So pretty much the same type of problem. Set up your rational function. So I'm going to do the same thing. So T of R is going to be distance over R. So T of R is going to be 308.6 over R. And then you draw you sketch your graph according to the calculator, okay? All right. According to Google, the trip should take 5 hours. So time is 5 hours. What is your rate going to be? So you could cross multiply. You have 5R equals 308.6. So R equals, when you divide by 5, R is going to be equal to, I think, 61.72 mph. Now, with D, you are told to determine the vertical asymptote for T of R. So remember, vertical asymptote is solving the denominator, equating the denominator to 0 and then solving for your input. In this case, it is R. Now R equals 0, so that will be my vertical asymptote. Now it says write a sentence explaining its significance. So what would it be? As the rate gets closer to 0, the time increases, right? As the rate gets closer to 0, the time increases. Now, if the rate actually equals 0, you will never get to Las Vegas. And it doesn't make sense, right? And that is why this is an asymptote, right? So the graph approaches that line, R equals 0, but it's never going to touch it because you're traveling. right? So you're not stopping, which means you are not traveling anymore. It doesn't make sense. So as the rate gets closer to zero, the time increases. If the rate actually equals zero, you will never get to your destination, right? You never get to your destination. Now, what about the horizontal asymptotes for T of R? Remember, from our function, we have this for T of R. Now, because R is our input, when you look at the numerator, what is the highest degree R term? It's just 308.6 because you only have one. So we have 308.6. At the bottom, what is the highest degree R term? Is R. Now, if you go back to our horizontal asymptotes cases, with this kind of case, when you have a number over x or the input, we say that y equals 0. So at this point, we say T of R equals 0. T of R equals 0. Which means that to write a sentence, as the rate increases, the time decreases. As the rate increases, the time decreases. If the time actually equals 0, you will not have traveled any distance. And this does not make sense in the problem. Because if time is 0, then it means you are still home. You didn't go anywhere, or you've not started traveling. So this doesn't make sense. It means you never traveled. All right? Now, I want us to look at this problem. Now, you have Sue and Jim working together, can rake the yard 2 hours. So if they work together, they can rake the yard in 2 hours. Now, when they work separately, so Sue will do 3.5 hours. And then Jim, we don't know how many hours Jim is going to use. Okay? So we don't know how many hours he is going to use. So how do we, it says, how long would it take Jim to rake the yard if he worked alone? Now, the number of hours is going to take Jim is T, right? So let's say that we want to find the fraction of the load completed in 1 hour. For Sue, is going to be 1 divided by 3.5. The fraction of the load completed in 1 hour. For Jim, is going to be 1 over T. Now, for the total fraction of the load completed in 1 hour, that is when for both of them, we have 2 hours, so you have 1 over 2. Now, when you add this, it should bring you to that. So this allows me set up an equation. I'm going to go to the whiteboard. It allows me set up an equation like this: 1 over 3.5 plus 1 over T equals 1 over 2. Now, remember that the number at the top are all the same, right? And at the bottom, that is the information I was given. So the LCD of this, I'm going to multiply the 3 at the bottom. 3.5 times 2 is 7, times T is 7T. So I'm going to do 7T times everything on the left So 7t, if I distribute them, times 1 over 3.5 will give you that, right? Because it's 7t over 1, plus 7t over t, that is from this one, equals 7t over 2. Now t will cancel t. Now 7 divided for this one, 7 divided by 3.5 is 2t plus 7. 7 divided by 2 is 3.5t. Wow. So this becomes a very simple equation. Now, if I move this across, it changes to negative. So I have 7 equals 3.5t minus 2t. So I have 1.5t equals 7. I divide by 1.5. I divide by 1.5. So this gives me 7 divided by 1.5 is 4.67. Oh yeah. So Jim takes 4.67 hours to rake the yard. So I hope these videos help. Go into the media lessons and then watch those as well. And I think in all, it's going to give you a very good understanding. If you are still struggling on any of the questions, please reach out to me. Thank you.